Hello everyone. Am I audible?
Good evening, sir.
Good evening, Krishna, Ronaldo, Kulsum, Shikhani, Said. Everything good?
Yes, sir.
All right. Any doubts from the last class?
No, sir.
Krishna, any doubts? All right. So let's carry on. I hope you revised everything. In the last class we did. What did we do in the last class, Krishna?
So whether the given function is continuous.
Continuous or not, right? Absolutely right. So let me give you more thing. If a function f of x is continuous and its domain then we say this is a continuous function, right? There is a theorem related to this. Give me a moment. What does the theorem say? If f and g are two functions, are two continuous functions in their common domain, then f plus g will be continuous, f minus g will be continuous, f into g will be continuous, and f upon g will be continuous, given g of x is not equal to 0. All right. What does this say? This is saying if suppose f is sine x and g is x, there are two functions. Suppose they have common domain. The domains are same. Then this plus this will always be continuous if x is continuous and sine x is continuous. Sine x minus x will always be continuous. Same with multiplication, same with division, except when x becomes 0, because we don't want 0 in the denominator. This thing is clear?
Yes, sir.
All right, everyone else? Ronaldo, this is clear? All right, Kulsum, Said, Shikani.
Yes, sir.
All right, note it down. Done? Everyone?
Done, sir.
Let's write down a question. If a function f is defined as f of x equals to x minus 4 mod on x minus 4, if x is not equals to 4, and 0 if x is equals to 4, then show that f is continuous everywhere except x equals to 4. Write down this question. I'll give you a hint how to solve. First, write down this question.
Done, sir.
All right. So whatever I told you, whenever you see modulus functions, what you have to do? Whenever you see mod function, what you do?
We should keep plus minus.
Absolutely right. So how we can open this function? Mod of x minus 4 will open as x minus 4 with the positive sign if x is more than 4. Yes or no?
Yes.
And it will open as minus of x minus 4 upon x minus 4 when x is less than 4. And this is 0 when x is equals to 4. I hope this thing is clear to everyone. This is the important step here. Ronaldo, Kulsum, Saeed, Shikhani. All right, I just opened the modulus function. So this becomes f of x equals to, first is 1, x minus 4 upon x minus 4 is 1 when x is more than 4. This is minus 1 when x is less than 4 and 0 when x is equals to 4. Now they have not asked you to just check at 4. They have asked you to check at every point including 4. So how to show that this is continuous at every point? This is not possible to show that they're going to check for infinite points, right? So what we do? Let's k be a number, k be a real number. All right. So we assumed k is a real number, and we took case 1 where k is more than 4. K is more than 4. So any number which is more than 4, it can be 4.001 or infinite. It should be more than 4. For this, we can calculate the limit and the value of the function. So if k is more than 4, can anyone tell me what will be f of x?
1.
1. Absolutely right. So we can say f of k will be 1 here. What will be limit k tending to 4 f of x? Again, I can put f of x as 1. So what will be this value? What will be this value? Or we can, if you are getting confused, you can write like this: x tending to k, x tending to k. I hope this is more clear. What will be the value of this limit? This is equals to 1, right? Because this is independent of x. Is this thing clear or not?
Yes, sir.
So we are getting limit of f of x is equals to limit of f of k. So function is continuous for all real numbers greater than 4. I can write like this because I've assumed that k is more than 4, and I proved that this is true for all k. So this is continuous for all real numbers more than 4. This thing is clear or not, everyone?
Yes, sir.
All right, Shikhani, Ronaldo, Kulsum Said. All right, please note it down. Then I have to scroll down. Done, everyone?
Yes, sir.
All right. So we can take the second case. What will be the second case? K is less than
Less
4.
than.
Absolutely right. So we can write case 2. K is less than 4. So what will be f of k?
-1.
Minus 1. And limit f of x extending to k. What we can write? This is limit extending to k. What will be f of x?
-1.
Minus 1. So this value will be minus 1. So we can see limit f of x extending to k is equals to f of k. So function is continuous at all k less than 4. This thing is clear?
Yes, sir.
All right. Case 3. First note it down. Case 3 is k is equals to 4. Can you guys try to solve this for the third case?
Yes, sir.
All right. Kulsum Said, you can solve this for case 3.
Yes, sir.
All right. Try to solve. I'll give you 2 minutes.
Done, sir.
All right. So for the third case, we have to take LHL and RHL, right, Krishna?
Yes, sir.
So we can write LHL is equals to limit k tending to or x tending to 4 minus x tending to 4 minus f of x. And this will be equals to limit x tending to 4 minus, what will be the value of f of x?
-1.
Minus 1. So limit value will be minus 1. Same for RHL. This will be equals to limit f of x tending to 4 plus. And this will be equals to limit f of x will be
1.
1. So the answer will be 1. So we can already see that limit is different. LHL is not equals to RHL. So function is not continuous at x equals to 4. I hope this thing is clear to everyone.
Yes, sir.
All right. Ronaldo, All right, Kulsum, Sayed, Shikani, this is clear?
Yes, sir.
All right, so whenever they ask you to prove that or show that function is continuous at every point, then please make cases. Something is greater than this, something is more than this, and you will get the answer very clearly. All right, so let's solve another question. Note it down if anybody wants. Discuss the continuity of the function f of x equals to sine 2x upon x if x is less than 0, x plus 2 if x is more than equals to 0. Again, in this question, they are asking to discuss the continuity of the function. They are not asking you to check at a single point. They're talking about the whole real numbers. So what we have to do here? How to solve this?
So you should consider k as a real
Right.
number. Then.
And what will be the cases?
So x less than 0, x greater than 0, and x is equal to 0.
Absolutely right. So I'll give you a few minutes. Try to solve this. Everyone is clear? Ronaldo, Kulsum, Sayed, Shegani. All right. So try to solve this.
Done, sir.
Everyone solve this?
Just a minute.
Yes, sir.
All right. Everyone solve this?
Yes, sir.
All right, Ronaldo. All right, so I don't need to solve this. Anyone here wants me to solve this? Sayed, Kulsum, Shikani.
No, sir.
All right then. So
Sir,
this is clear. Yes.
K greater than 0 will be like K plus 2, right?
Let's see. Let me solve for k greater than 0. Anyone can help me solve this? K is greater than 0. So what will be f of k?
K plus 2.
K plus 2. Absolutely right, because when x is more than 0, this is the function and this is the function, we are putting the value of k, so k plus 2. Now limit extending to k f of x, this will be the function will be again x plus 2, so this will be k plus 2. All right, we can use direct substitution here. Krishna, this is clear.
Yes, sir.
So I hope this question is clear to everyone. Let me give you 2 questions for homework. So continuity is completed. Just write down these 2 questions. Discuss the continuity of the function of x equals to mod x upon x when x is not equal to 0 and 0 when x is equal to 0. Discuss the continuity of the function f of x equals to 2x minus 1 and 2x plus 1. This is less than 0. This is greater than equal to 0. Both of these questions are homework. I'll ask about them in the next class. Done, everyone? All right. Noted this down, right, everyone?
Yes, sir.
All right. So last topic of this chapter, differentiability. So what is differentiability? See, in limits, if there was a graph, we checked if there is a broken part of graph or not, if the graph is continuous or not. Now, differentiability gives us the smoothness of a curve. All right, if graph is like this or has sharp corners or broken, all of this can provided by differentiability. All right, so if a function is differentiable at some point, then the graph is smooth at that point. If not, then graph is having sharp corners like this. Is this a bit clear? What is differentiable and not? Yes or no?
Yes, sir.
All right, so write down the definition. Let f be a function in an open interval a to b and c belongs to a to b. Then f will be called derivable or differentiable at x equals to c if limit extending to c f of x minus c upon x minus c exists. Write this down. I'll explain what this means. All right, and this is the limit which is called the derivative. This limit is called the derivative of f at c and is denoted by f dash c. We already saw how to differentiate all the functions. Note it down. Hello, Ishan.
Hello, sir.
Everything good?
Better.
All right. We just started differentiability. This is the definition of differentiability. Please note it down. I'll be explaining this in 2 minutes.
Yes, sir.
Done, everyone?
Done, sir.
All right. So what this definition is saying let f be a function, all right, and the domain is a to b. Suppose this is 4 to 8 or any number it be, and c is any number in that domain. C is any number in that domain. Then the definition is saying if limit x tending to that number, that means at that point, if this limit exists, then function is differentiable at that point. All right, if at x equals to c or x tending to c, this limit exists, then we say the function is differentiable at c, and this limit is called the derivative of the function. All right, so what do we mean by limit exists? If limit exists, that means LHL should be equals to RHL, right?
Yes, sir.
So what will be LHL here? Limit x tending to c minus f of x minus c x. This is f of c. So all right, f of c. Limit x tending to c minus this is called LHD, left hand derivative of f. All right, and limit x tending to c minus f of x of c x minus c plus is called RHD. RHD means right hand derivative. Here we do not say LHL or RHL, we say LHD and RHD. Rest of this, the concept is same. C minus and C plus. All right, C minus means a number little bit less than C. C plus means a number little bit more than C. Is this thing clear or not?
Clear, sir.
All right, so if anybody asks you to find the function is differentiable or not, you have to find this limit and this limit, check if they are equal or not. Very simple, note it down.
Done, sir.
All right, and don't worry, I'll explain where this thing came from. Don't worry. But before that, let's do one or two questions so that this thing is clear. All right. Everyone has noted this down? Yes or no?
Yes.
All right. Solve this. You don't have to write like this. Mod x. F of x is mod x is differentiable or not. So what we have to do? LHD. Can anyone tell me what will be LHD here?
So mod x minus mod c by.
whenever we see mod function, what we do? Whenever we see mod function, what we do?
X greater than 0 and
Yes,
minus
your voice is starting to break. Alright, mod x will be x when x is greater than or equal to 0, minus x when x is less than 0. Now we can find LSD and RSD. So what will be LSD? You can check the formula. X tending to 0 minus f of x minus f of c. C is 0. So f of 0 upon x minus c. 0. This thing is clear, everyone?
Yes, sir.
All right. So what will be f of x here? What will be f of x here? Minus x, absolutely right. And minus f of 0 is? What is f of 0?
0.
0. And here x, and we can write this limit h tending to 0 minus 0 minus h. I hope you remember left hand limit. We put x equals to 0 minus h. So h will be tending to 0, 0 minus h, minus 0 we can leave, and this is also 0 minus h. So finally we have limit h tending to 0. This is plus h upon minus h, which is equals to minus 1. This thing is clear or not?
Yes, sir.
All right. Now RHD, right hand derivative. This is limit x tending to 0 plus f of x minus f of 0 upon x minus 0. Now limit x tending to 0 plus, what will be f of x here? X. So x minus 0 upon x minus 0. We can put h tending to 0, 0 plus h upon 0 plus h, and this is obviously 1. This thing is clear or not?
Yes, sir.
Yes, sir.
So LHD is not equals to RHD. So function is not differentiable at x equals to 0. This thing is clear or not?
Clear, sir.
All right. Kulsum, Saeed, Shikani, Ishan.
Yes, sir. Clear.
All right, please note it down. All right, done.
Done, sir.
Let's try to solve the question. Show that function f of x equals to x minus 1 and x is less than 2, 2x minus 3 and x is greater than or equals to 2 is not differentiable at x equals to 2. All right, try to solve this. All right, Shekhani, but please get the lecture. All right, and complete it, because in the next class there will be exam of this topic. Anyone solve this?
Yes, sir. Done.
All right. What about the rest of you? All right, Ronaldo. Kulsum Saeed. Saeed, your voice is not audible. Let's see. LHD. What is LHD? Krishna?
So limit extends to minus.
Your voice is breaking, Krishna. So limit x tending to 2 minus f of x minus f of c upon x minus c. So this will be equals to limit x tending to 2 minus f of x. So when x is less than 2, this is the function. So x minus 1 minus f of 2. So f of 2, you can tell me what is f of 2 here?
2x minus 3.
Yes, but we have to put the value of x as 2 also, right? So 4 minus 3, or we can say 2 into 2 minus 3. Yes or no?
Yes, sir.
So x minus 2. Now put x equals to 2 minus h. So h will be tending to 0. We can write this as limit h tending to 0. And this is x minus 1 minus 2, x minus 2. So 2 minus h minus 2 on 2 minus h minus 2. I hope this thing is clear. So here LST is 1. Yes or no?
Sir, I
Everyone,
didn't
this
get the
is
part of f of c.
f of c. All right. We have to find f of 2. So what will be f of 2 when x is equals to 2? We have to put this as the function, right, Krishna?
Yes, sir.
So you have to put x equals to 2. So 2 into 2, 4, minus 3 is 1. And 1 minus 1, minus 1 minus 1 is minus 2. All right.
Okay, sir.
Kulsum, Saeed, Ishan, this is clear?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So RST will be limit extending to 2 plus f of x minus f of c upon x minus c. Limit extending to 2 plus f of x will be 2x minus 3, and this is, as we have already seen, minus 1 upon x minus 1. Putting x equals to 2 plus h and h tending to 0. This will be limit h tending to 0. So we can take 2 common. Let's just write 2 into 2 plus h minus 2 whole divided by 2 plus h minus 1. So this is, now put h equals to 0. We get what answer? 2. Limit h, or directly you can put h tending to 0. This is 4 plus 2h minus 2 upon 1 plus h. Put h equals to 0 directly, we have no issues. So 4 minus 2, 2 upon 1 is 2. So we can see LHT is not equals to RST. So function is not differentiable at x equals to 2. This thing is clear or not, everyone?
Clear, sir.
All right. Ishan, Kulsum, Saeed, Ronaldo. All right. Just note it down. I'll give you 2 minutes to write it down.
Done, sir.
All right. Now, how did we get this formula? Let's understand that. How this is the differentiation. Suppose this is the function given to us. This is a point A, this is B, and this is C. All right. Suppose this is x equals to C, or let's call this x equals to K. So the value will be, this will be K comma f of K. Yes or no? The coordinates of B,
Yes, sir.
simple coordinate system. And suppose this is K minus H, a small quantity lesser than K. So we can call this is K minus H comma f of K minus H, K plus H. So this will be K plus H comma f of K plus H. So we located 3 points with these coordinates. If I draw this line here and this line here, I believe nobody has any issues with me drawing lines. Now, what is differentiation? We know change of y with respect to change in x. Yes or no?
Yes, sir.
So if I'm looking at A to B, what is the change in x? What is
So
the change
H.
in x? H. Or what we can say, k minus h, right? Right? Yes or no?
Yes, sir.
And change in y?
F
This
of
is
H.
f of k minus f of k minus h. Right, Krishna? This is how to check the change in y. This y minus this y. Yes or no?
Yes, sir.
So differentiation we can write the change in y with respect to change in x. All right. So this is y2, y1, x2, x1. Can anyone tell me what this represents? If 2 points we have x1, y1 and x2, y2, then y2 minus y1 upon x2 minus x1. What is this? Not distance formula. This is the slope of the line AB, right? Slope of line AB. Ronaldo, this is clear. Slope of line y2 minus y1 upon x2 minus x1. So we can say the change in y with respect to x is nothing but the slope of line AB. So we can directly write now slope of line CB will be equals to f of k plus h minus f of k upon k plus h minus k. I hope this thing is clear. Yes or no?
Yes, sir.
Now differentiation calculates this change when the change in x is very small. So I can write f limit h tending to 0. That means the change in x, right? This is k minus h, this is k. So change is h So if I make this change almost zero, then I can say this is the left hand derivative. And this is the right hand derivative. All right.
Yes, sir.
So I think this is clear to everyone. Now you can change this. This is x, and before or c, this is x plus h. This is x minus h. We'll get the same formula as before. The namings are different. That's all. All right. So we can write this is the LHD left hand derivative. This is the RHD right hand derivative. So we can say if LHD at a point or at x equals to p is equals to RHD at x equals to p, then function is differentiable. Function is differentiable at x equals to p. Please note it down. All of this very important. Everyone is clear? Yes or no?
Yes, sir.
What I did? All right. I don't think this is too heavy for anyone here.
So can you just show the graph also?
All right. All right.
Yes, sir.
And you can look at the graph. One more thing. If this change is very small, that means these 2 points are very close to this, right? So this line becomes a tangent. I'll come to that. Just note it down first, then I'll explain what I mean by that.
So can you scroll down? Done, sir.
All right, everyone done? All right. So now let's look at a different way of thinking this. If I join 2 points like this, they are very far. So line will look like this. If I take this point to a bit closer to the previous point, then line will look like this. If this point comes more closer, then line becomes like this. So we can see the line is shifting towards the curve. So if the point is here, so line will look something like this. If the difference between them is infinitesimally small, at least like no difference at all, suppose, because we know h is tending to 0, so difference between them is tending towards 0. So if this happens, then the difference becomes this, the line becomes a tangent. So when differentiating, what we get, the slope of the tangent at that point. If you are finding the differentiation at c, then what we get, dy by dx will be equal to the slope of the tangent at this point. This thing is clear?
Yes, sir.
So if function is differentiable, then we can say there exists a unique tangent at x equals to c, right? Because the function is differentiable, that means there will be a single slope. So if there is a single slope, that means only one line can pass through that point with that slope. So a unique tangent at x equals to c. Note it down. Done?
Done, sir.
All right. So this is all about the theorem of differentiation. Now some specific points to remember. All right. If a function is differentiable at x equals to c, then it will be continuous at x equals to c. But the converse is not true. What this means, if a function is differentiable at x equals to c, if we have given a function and we are saying there exists a unique tangent here, so limit exists at that point, and if limit exists, that means the function is obviously continuous, right? If there is no function there, then how can we find tangent? So if we can find tangent, that means the function is automatically continuous at x equals to c. But the same is not true for the converse statement, because we know mod x, all right, modulus function, not this graph, this one, this function is continuous, but we have two tangents here. So this is not differentiable. We just solve the question, solve this question, mod x at 0, that was not differentiable, right?
Yes, sir.
Mod x is not differentiable but continuous. So this is a very important statement. What is the next one? If a function is not continuous at x equals to c, then it is not differentiable also. Alright, if it is not continuous, then how we can say this is differentiable, right? The function is breaking and there cannot be a tangent. Note it down. Done everyone?
Done, sir.
All right. Few more points. If LHD at P is equals to RST at P, then function is differentiable at P, and it means that there exists a unique tangent at P, which in other words mean P is not a sharp corner. Right? As I told you, this means P is smooth curve, not sharp corner. All right. If function is not differentiable at P, then either P is a corner point or is discontinuous at P. So when solving questions, always remember this: if a function is not differentiable at P or at any point, then there can be two cases for that. Either the function is continuous and it has sharp corner, or the function is not continuous at all. So always think about these points, write it down.
Done, sir.
All right. Write down a question. Show that the function f of x equals to mod of x plus 1 plus mod of x minus 1 is not differentiable at x equals to minus 1 and x equals to 1. This is a homework question. All right. So how to solve this type of questions? What is the first step? What you have to do when you see modulus function?
Sir, you should open it and in case of positive and negative case.
Absolutely right. So whenever you see modulus function, you can open the modulus function and then solve. All right. And this is for boards. But if you ever see like in competitive exams, then you already know the graph of modulus function. So this is not differentiable, is very obvious. All right, note it down. All right, and solve this question. Now, I'll give you a few minutes. You guys can solve this, right?
Yes, sir.
All right.
Done, sir.
All right, everyone solve this. All right, Kulsum says, Ishan. All right, so how we can solve this? Do you want me to solve this or we can move on?
Sir, I want to clarify if f-1 is 2. That's right.
All right, let's see. So LSD, you can differentiate this, right, Krishna, if you just have to clarify. But all right, let's see.
No, sir, the last one.
So x tending to 1 minus f of x minus f of c upon x minus c. So Krishna, what to write here? In place of f of x
So x square
and f of 1
1.
upon x minus 1. So putting x equals to 1 minus h tending to 0, we get limit h tending to 0, 1 minus h whole square minus 1 upon x minus 1. Sorry, 1 minus h minus 1. This is clear?
Yes, sir.
So minus 1 is cancelled here. So limit h tending to 0, 1 square plus h square minus 2h minus 1 upon minus h. So this is also cancelled. So what we get finally, limit h tending to 0, taking h common, h minus 2 upon minus h. So this is cancelled. Now we can directly put h equals to 0. So the answer is 2 on LHB. All right, Krishna.
Yes, sir.
And for RST also we can do the same. Limit extending to 1 plus f of x minus f of c upon x minus c. So limit extending to 1 plus x square minus 1 minus x minus 1. Put x equals to 1 plus h tending to 0. So limit h tending to 0, 1 plus h whole square minus 1 upon 1 plus h minus 1. This is cancelled. This is limit h tending to 0, 1 square plus h square plus 2h minus 1 upon h. This is cancelled. Again, taking h common. So we can cancel this thing, h0. So again, 2. So we can say LST equals to RST, which is equal to 2. So function is differentiable. So f is differentiable at x equals to 2, and f dash, what value they are asking?
1.
1. All right, so f dash 1 will be 2, because we just figured out differentiability at 1. So any value of LSD and RST will be the derivative. All right, Krishna,
Yes, sir.
everyone is clear about this? Ronaldo, Kulsum, Saeed.
Yes, sir.
All right, so note it down if you want. Another question for homework?
So it will be 2 for any value.
No, not for any value. See, we figured out LSD at which point,
1
and RST at which point?
at once.
So we just checked at 1, the differentiability at 1, and we saw that the function is differentiable. And what are they saying? To figure out the derivative at 1. So that limit itself is called the derivative. All right.
Yes, sir.
So if they ask f dash 2, then how we can do? Either you can figure out this limit, or you can just differentiate x square, right? Because we know that x square graph is a parabola, like in competitive papers, not CBSE. If they ask to find if the function is differentiable at 2, then you have to do this limits. All right, one question for homework. For what choice of a and b is the function f of x equals to x square, x is less than c, ax plus b, x is more than c, is differentiable at x equals to c. Write this down. This is homework question. I will not be sending assignment today. You all have to do the homework questions. Note it down. Tell me when you are done.
Done, sir.
All right. Some useful results on differentiability. Why are they useful? Because you can use the information here directly while solving questions. What are the information? Every polynomial function is differentiable in its domain. This x belongs to R. I hope you know what is polynomial function. This is the polynomial function a naught x to the n plus a1 x to the n minus 1 and bn x to the power 0. Right? This is the polynomial function. Every polynomial function is differentiable in its domain, that is x belongs to R. If any questions ask you about this, you can write directly that this is the polynomial function and polynomial function is differentiable at every point. All right.
Yes, sir.
Same about this exponential function. Every exponential function is differentiable in x belongs to R. Exponential function is a raised to the power x, e raised to the power x, and so on. All right, note it down. I have to scroll up then.
So we can say these are true for continuous also, right?
Yes, polynomial function, exponential function are continuous in its domain. All right, but this is not true for all the functions we are going to write. All right, for these two, this is true. You can say if they are differentiable, they are continuous because we are cancelling out. I'll explain in the fourth point. All right, right? Every constant function is differentiable and x belongs to R. What is constant function? Y equals to C, right? Is constant value. Every logarithm function is differentiable in its domain. And trigonometric functions and inverse trigonometric functions are differentiable in their respective domains. All right. So in this type of questions, if they Krishna, if they give you any point which you know that doesn't belong in the domain, and they ask you to find continuity, then you have to check, right? Because we know tan function breaks, right? Sec function breaks. So in this type of points, you have to check. All right.
Yes, sir.
Note it down. Last point is there. If two functions are differentiable, then they are sum, subtraction, or difference, product, and division is also differentiable. All right. So if you have two differentiable functions and you add them, then the third function is also differentiable. If you multiply them, then also that is differentiable. And this is very important to know. Note it down.
So what's the word after two? If two.
Which, all right, if two functions write down this question also. This is also for homework. And we'll discuss this question in the next class. Write this down.
Yes, sir.
All right. So in this question, they are asking you to discuss differentiability of this function. They are not asking to calculate its specific points. So what we have to do?
So we have to take cases.
Absolutely right. And what will be the cases here?
So k is greater than 1, I mean less than 1, and k greater than 1, less than 2, k greater than 2.
Right. And then you have to check at 1 and 2 also. Right, Krishna?
Yes.
So you have to make many cases, but good for you that you can use these properties when solving this question. All right.
Yes, sir.
So everyone is clear about this? Ronaldo, Kulsum, Saeed, Ishan.
Yes, sir.
All right. And in the next class also, there is going to be a test of this chapter, continuity and differentiability. So revise accordingly and see you in the next class, guys. Take care.
Thank you, sir.
All
Thank
right.
you, sir.
All right.